Hello dear students, welcome to BYJU'S exam prep. Now under this concept capsule series, let us take up one small concept from data structures, that is Polish notations. And before that, this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience and my qualifications are M.Tech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. I am associated with BYJU'S from past 1 year and I am working on a different project which is called Recorded Gate Content. We created visualized animated gate content for you people. Under BYJU'S exam prep app, under the category Learn with Video Lessons, you can find all these subjects which were recorded by me. Data structures, algorithms, engineering mathematics, C programming and data structures. Okay, please go through these videos, my dear friends. Now let us start with today's concept, that is Polish notation. Before starting with Polish notation, we need to understand what is this arithmetic expression. An arithmetic expression consists of operands and operators. Let us take up a simple example, A star B. Here A and B are operands and star is an operator. But in general, the operands can be variables, constants, or the operands can themselves be another arithmetic expression. And what about operators, my dear friends? The symbols representing mathematical or arithmetic operations, relational operations, or logical operations. Am I clear? And variables and constants can be joined by various operators. Okay, the variables, constant, even arithmetic expressions can be joined by various operators to form what is known as a compound arithmetic expressions. But generally these arithmetic expressions are given in the form of infix notation. That is, the notation which we use is given a special name and we call it as infix notation. Even this A star B is infix notation, my dear friends. But for using this infix notation, we need to know the precedence as well as associativity of operators. So infix notation needs operator precedence and associativity for evaluating the expression. Precedence means which operator is having higher precedence and which one is having lower precedence. So we have the precedence of operators, and every programming language will be having this particular precedence of operators. And again, if the operators are having same precedence, within that associativity, whether they are left to right or right to left associated, we need to mention. So this precedence as well as associativity is required if you want to evaluate the expression, my dear friends. Example, suppose if I give you an infix expression 2 plus 4 into 5. There are two possibilities. One possibility is it can be 2 plus 4 into 5, where 4 into 5 is, okay, sorry, here it is like, first here we are doing 2 plus 4. Suppose if precedence and associativity is not mentioned, that's what I am saying. If precedence and associativity is not mentioned, first you can find 2 plus 4 which is 6, then it can be multiplied with 5 which is 30. Or the second possibility is, first you can multiply 4 and 5, the result is 20, that can be added to 2. Generally this is the correct precedence, my dear friends, because we know that multiplication is having higher precedence than addition. But if you do not have this precedence, this way it can be solved or this way also it can be solved. Am I clear? So for evaluation of expressions having more than one operator, we use precedence and associativity rules. See, sometimes what happens, suppose if we are having 2 plus 3 plus 5, both are additions. In this case, we need to know whether you are going to add from right to left or left to right. Am I clear? So here it does not make 2 plus 3 5, 5 plus 5 is 10. But what about this 2 minus 3 minus 5? If you don't have associativity rule, if you do from left to right, it is 2 minus 3 is minus 1 minus 5, the answer is minus 6. But if you do it from right to left, 3 minus 5 is minus 2, minus of minus plus, therefore it becomes 4. The result will be different. Am I clear? So the associativity also plays very important role, my dear friends. Am I clear? So that is the problem with infix notation. Okay, let me clear this. An algorithm to process infix notation could be difficult and costly in terms of time and space consumption, because we need to know the precedence of operators, again associativity also, if you want to evaluate the expression which is in infix format. Now we introduce what is known as prefix notation. Prefix notation is also known as normal Polish notation or Polish notation, and it is invented by the Polish mathematician Jan Lukasiewicz in 1920s. So let us understand what is this prefix notation. In prefix notations, operators are written before their operands. Operator precedes before their operands. Let us see example. Now look at this. Here this is operator and these two fellows are operands, and here if you observe, operator precedes operands. Operator precedes operands, and that is what we call it as prefix notation or Polish notation, my dear friends. Now let us see this example. The rules for prefix notation. Suppose even this is prefix notation. Operator act on values immediately to right of them. So here operator, this is operator, this acts on values or operands which are immediately to right of them. Again this becomes a single operand now. After applying plus BC, that becomes a single operand. Now this operator operates on 1 and these two. Am I clear? Then next operator minus operates on, now this becomes a single operand, my dear friends. Now this operator operates on this followed by D, my dear friends. Okay, so operator act on values immediately to right of them. Then brackets cannot be used to change the order of evaluation. See, for example, if it is a infix notation, if you want, for example, normally multiplication will be having higher precedence, but if you want to give plus higher precedence, we can use brackets. But for prefix notation, we cannot use brackets to change the order of evaluation, my dear friends. Please note that. And the order of evaluation of operator is always from right to left. So here, when you want to evaluate this expression, you start from right to left. So we move from right to left. Whenever you see operator, you immediately operate that operator on operands immediately to the right of it, first and second. Then you move to the left, you find the operator. It is operated on operand. Now this becomes an operand, my dear friend. This entirely plus BC becomes an operand. So this star is operated on these two fellows. Again when you move left, because you are going from right to left, when you move left, minus will be operated on, this is 1 and this is second. Am I clear? So this is how the expressions are evaluated, my dear friends. Is the idea clear? Now comes postfix notation. What is this postfix notation? Postfix notation is also known as reverse Polish notation, and it is also invented by same Jan Lukasiewicz in 1920s, my dear friends. In postfix notation, operators are written after their operands. Okay, now let us see the example. A, B star. Here what are the operands? A, B are the operands. And what is operator? Star is operator, and operator is written after the operands. Now let us see the example. Now this is an example for postfix notation. Now here operators acts on values immediately to the left of them. Operators act on the values or operands immediately to the left of them here. In prefix, immediately to the right of them, here immediately to the left of them. Brackets cannot be used. We cannot use brackets to change the order of evaluation. That is only possible for infix notation. The order of evaluation of operators is always from left to right. Here the evaluation goes from left to right, my dear friends. So here when you go from left to right, whenever you see any operator, it is operated on the two operands which are immediately to the left of it. Then again you see star. Now this becomes an operand, my dear friends. So this star is operated on two operands which are left of it. That is this BC star, BC plus whatever is there, no? That one followed by A. Am I clear? Now again you see minus, this is one operand and this is second operand, my dear friend. So this will be operated on this. So this is how the postfix expression is evaluated from left to right. Am I clear? Note, in all the three notations, the operands occur in the same order. See, for example, if you take infix notation, the order of AB is same. Only operator comes in between operands. Whereas in prefix notation, AB will be in the same order. Their order is not changed. Only operator comes before operands. Whereas in postfix notation, AB are in the same order, but operator comes after the operands. So here you see, only this fellow position is changed. AB relative order is always same. AB, A first, B next. Only star in the infix it comes in the middle, in prefix it comes in the left, in postfix it comes after that. That's it. That is the only difference, my dear friends. Hope you understand. Now let us see how to convert an infix expression to prefix and postfix expression, or postfix and prefix expression. Let us see both. First method, let us see method wise. There are two methods. Method 1. In method 1, we try to use the parenthesis, then we try to convert the simplest forms into corresponding prefix or postfix, then finally we get the required answer. So here we should properly parenthesize this expression, A star B star C, because multiplication is left to right associative, so A star B star C. So this is the order of evaluation, my dear friends. So if you want to write prefix expression for this, what we do is, see, we start from the outermost fellow. Let us simplify this. What is A star B? Prefix notation. Prefix notation of A star B is star AB. So this is your operand, star C. Now this is operand and this is operand. Again you convert into prefix notation, sir. What is prefix? Operand, next operand, and operator precedes it. So this is your prefix notation for the given infix, my dear friends. What about postfix notation? The idea is same. First you write this in parenthesized form. Now what you do? You simplify this. A star B's postfix. What is A star B's postfix? AB star C. Now this is an operand and this is an operand. Again convert this. Okay, let me give a small line here so that you can distinguish between prefix and postfix. Now what? Now this is operand and this is operand. Write the postfix for this. What is postfix for this? AB star C, two operands followed by operator. This is method 1 for converting infix expression. These are manual methods, my dear friends. Okay, these are manual methods. Am I clear? I am just trying to explain what is this prefix and what is this postfix expression. Am I clear? Please try to understand. The second method is, we create the expression tree for this. For the given expression, we create an expression tree. From that, we are going to write prefix and postfix. And the prefix and postfix notation can be written simply as you write your pre-order and post-order for binary trees, my dear friends. Okay. So the idea here goes like this. So it is A star B star C. Of course, this is your method 2. This is your method 2, my dear friends. So what you do, you try to write the expression tree for this. So what is the final operator here? This is final operator. So this is operated on left, which is A star B, right, which is C. Am I clear? Now what you do, write this A star B. How you write this A star B, my dear friends? Let me write it here. Again A star B, you write the expression tree for this. Star A B. So this is how we can construct the expression tree. Once you write the expression tree, you can write the prefix and infix notation similar to that of pre-order and in-order traversal, my dear friends, in a binary tree. Even this is a binary tree only, my dear friends. Okay. Now what happens? You start from here. Every node is visited 3 times. Left, left, middle, right. Now this is middle. This is left, middle and right. Right, middle, left, middle, right. Right and go. And you can give numbers, my dear friends. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So you traverse from left and you go till right, my dear friends. While traversing, if you want to write the prefix notation, you need to print the nodes whenever you get 1. Then it is prefix notation. You print the node whenever you get 2, then you get infix notation. You print the node whenever you get 3, then you get postfix notation. That is the simple method, my dear friends. You can start from here. Okay. Now let us see prefix. We have to print once. So 1, you have to print the node. What is it? Star. Then you go here. Again 1, print the node. That is star. Again you see 1, that is node A. Then you continue 2, 3 you ignore, 2 you ignore, 1. 1 means print the node. Again 2, 3 you ignore, 3 you ignore, 2 you ignore, 1. 1 means print the node. That is C. That is prefix notation. Continue this way and you can get the complete prefix notation by difference. Now what about postfix? Because already infix is there, I am not writing it. What about postfix notation, my dear friends? For postfix you start from here, but you print the node whenever you find the number 3. At 3 you print the node. 1 you ignore, 1 you ignore, 1 you ignore, 2 you ignore, 3. Once you find 3, print the node. A is printed. Then again continue 2, then 1, then 2 you ignore, 3. 3 means print the node. B. Continue star, print the node. Continue 2, 1, 2, 3. 3 you print the node. Continue 3 you print the node. That is star. And that is your postfix notation, my dear friends. Is that simple? Good. Let us take one more example. One more simple example. Okay. Let us do by both the methods, my dear friends. Method 1. Method 1, what you do? First you write down complete parenthesized expression for this. Am I clear? Then we write prefix for this. So how you write this? This A star B prefix notation. Star AB plus C. Now this is operand and this is operand. Again prefix for this. What is prefix for this? Plus is operator. Star AB operand. C is operand. And you got prefix notation. What about postfix notation, my dear friends? Same story. Write the outside parenthesis as it is, plus C as it is. Now simplify this. What is A star B? Postfix notation. AB star. Now this becomes operand and this becomes operand. Now again postfix notation for this. What is postfix means? Operand, operand followed by operator. And that is your postfix notation for the given infix, my dear friends. Is the idea clear? Of course, as I told you, you can also write the expression tree, and from that also you can write the prefix and postfix notations. Let us write them. So the final operator here is plus A star B and C here. Again A star B can be written as star A B and this is C. Once you got this expression tree, you can construct. This is called Euler walk or walk, whatever you call it. Left, 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 middle and right. Middle, left, middle, right. Right, middle, left, middle, right. Right and go. Okay. Now you start your walk from here. You can give the numbers as I told you, 1, 2, 3 at each node. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Some people write left, middle and right. You can write that way also. So for prefix notation, you have to walk, and whenever you find 1, you have to print the node. 1, print the node. 1, print the node. 1, print the node. Continue, continue, ignore 2s, 3s. 1, print the node. 2, 3 you ignore, 3 you ignore, 2 you ignore, 1, print the node. 2, 3, 3, continue. Done. What about postfix notation, my dear friends? Postfix notation. Same traversal, start from here. You have to print 3's now. That is, whenever you find 3, print the number. Continue 1, ignore 1, ignore 1, ignore 2, ignore 3. 3 you print. Continue 2, you ignore 1, 2, you ignore 3. 3 is printed. Again continue 3, star is printed. Continue 2, 1, 2, 3 is printed. Then finally 3 is printed. And this is how we can get the postfix notation. And this is the concept of the Polish notation, my dear friends. The prefix notation is called Polish notation, whereas postfix notation is what is known as reverse Polish notation, my dear friends. Okay. So please subscribe to BYJU'S Exam Prep YouTube channel and also download this BYJU'S Exam Prep app. If you purchase the course, you can watch all the video lessons, my dear friends. Otherwise also, you can see some of these video lessons under this Learn with Video Lessons category. Please do subscribe to the channel. Thank you.